So in this lab, we'll be using Hooke's law to find the spring constant of the given springs. So you should have this pouch with 8 to 9 springs. Some of you may also have 10 springs. So you will be finding the spring constant for each of these springs. Okay? So to find the spring constant, we'll be plotting the force versus displacement. Okay? So we need to pull the spring by each of these distances. So we'll pull by 1 centimeter, 2 centimeter, 3 centimeters, up to 10 centimeters, or up to the distance that will not deform the spring. Okay, we don't want to deform the spring. And we will find how much force we need to pull the spring by all these different amounts. So the first thing I would like you to do is take a ruler and then fix the ruler using these tape pieces on some table. Okay, we'll start with the first spring. So we'll start with this spring. For spring 1, we'll identify this by its length. So measure the length of this. So its length is 2.9 centimeters. So we'll write spring 1 as 2.9 centimeters. Insert this hook in the spring, and you'll keep the one end of the spring at the 0 mark here on the ruler. Okay, and you'll be using the centimeter scale, not the inch scale. Okay, we don't want inch scale, we will use centimeter scale, and you will keep this end fixed. So you will need to hold this fixed, and then on the other end you will connect this spring scale. So insert that hook in that end, and then here again you will keep this end of the spring at the 0 mark. So we'll keep that fixed, and now we'll pull this spring by 1 centimeter distance. 1 centimeter is, in terms of meters, is 0.01. Okay, so now first thing is you need to see if this is perfectly aligned at 0 or not. When you're not applying any force, this should give you 0 reading. So see if it is 0 or not. If it is not 0, you can rotate this until it aligns with 0. Now let's pull this by 1 centimeter. So see how much force you're applying. So you will need to stand to see that. If you sit on a chair and look at the reading from the side, you will not get the right reading. So you need to stand and look from the top. Okay, now hold the spring and this measuring scale so that the spring is not stretched. So now stretch the spring by 1 centimeter and see how much force you're applying. So here you're applying about 1.5 division, and each division is 1/10 of a kilogram. So that means it's 0.15 kilogram. So later I will show you how to change from kilogram to Newton in Excel. Again, take it back. Now stretch it by 2 and see how much force you're applying. So here you're applying the force of about 0.25. So that's 0.25, and then stretch it by 3. Now it's about 0.4. Stretch it by 4 centimeters, and it's about 0.5, and then stretch it by 5. That's about 0.6, and then you need to move it back. Actually, you tend to displace the 0 mark. So always keep in mind that your one end of this spring should be at the 0 mark. If you displace that, you will not get the right answer. So now stretch it by 6. So that's about 0.8 something. So we'll call that 0.81, and then put it back at 0 mark, and then stretch it by 8 centimeters. Now it's about 1 kg. And again, make sure that the spring is not deformed. Okay, you need to pull it only until it can still come back to its equilibrium. Once it's deformed, it cannot come back to its equilibrium state. So 9 would be 1.2. Actually 1.2, 9. Did we do 8? So 8 would be, let's go back here. So 8 centimeters would be 1.1, and then let's do 10. we may not be able to go above 10 because it's almost too much force. So it's 1.35. Okay, so that's our data. Now you will do the same thing for other springs also. You have a bunch of springs here. Now you can choose this one. So measure the length of this one. So that will be our second spring. So that's 1.5 centimeters. So that's 1.5 centimeters. You do the same thing. Hook this on one side and then hook the scale on the other side. So you will fix this end at the 0 mark, and then you pull by 1 centimeter. See how much force you're applying. 2 centimeters. Keep in mind that when you're pulling it, do not fix this on the ruler. So try to move it slightly above the ruler so that it doesn't drag. If you drag the spring, that may give you wrong force. So try not to drag it. Rather, it's slightly above the ruler so that there's no drag force. So that's 1, that's 2, measure the force, that's 3, measure the force, that's 4, 5, 6. So one thing you can do here is maybe record your voice on your phone recorder, okay, and then you can write the data listening to the recorded voice. Okay. In that way, you don't have to remove your hand from the scale while writing the numbers, because if you just continuously do this, you will get more accurate data rather than removing your hand and writing and then going back. So in order to get a better data, you can just record your voice on your phone recorder. Okay, so you will do this same thing for all these given springs. Okay, and then in the next video I will show you how to plot the data on an Excel file.